Welcome to Civil Engineering Fanatics. Today, we will be discussing the concept of the shrunk scale used in civil engineering drawing and surveying. A shrunk scale, also known as a reduced scale, is a correction factor used in surveying to account for the shrinkage of survey materials, like paper or plastic, on which plans and maps are drawn. When a map or plan is created, it is drawn using an original scale, which accurately represents the real-world dimensions on a smaller scale. However, over time, the material on which the map or plan is drawn, such as paper or plastic, may shrink due to environmental factors like temperature and humidity. Understanding and applying the shrunk scale ensures that the measurements and representations remain accurate, despite any changes in the physical dimensions of the survey materials. The concept of a shrunk scale can be understood by looking into how a plan or map is initially drawn to an original scale. Let's say, I have to plot a proper rectangular area on a map with dimensions of 50 meters by 80 meters. The area is marked as ABCD, where AB equals 50 meters and BC equals 80 meters. I plan to represent this area on the map with a scale where 1 centimeter on the map equals 10 meters on the field. To calculate the representative fraction, RF, we proceed as follows. 1 centimeter on the map equals 10 meters on the field. Thus, RF equals 1 centimeter by 10 m. When simplifying, we convert both the numerator and the denominator to the same unit. Therefore, 10 meters becomes 1,000 centimeters. So, RF equals unit on the map divided by unit on the field. That gives 1 by 1,000. Therefore our scale is 1:1,000. Now, how can we represent the area on the map? The length of side AB is 50 meters, which equals 5,000 centimeters. On the map, we will plot AB with a measure of AB into RF equals 5,000 centimeters into 1 divided by 1,000, that gives 5 centimeters. Similarly, side BC, which is 80 meters, will be represented as 8 centimeters on the map. Thus on the map, we take 5 centimeters and 8 centimeters as the sides of the rectangle, which corresponds to 50 meters and 80 meters in field, as shown on the map. In the rightmost corner, we mention the scale as 1:1,000. As we are representing a larger dimension from the field on the map using a reduced dimension, this is called a reducing scale. As we have understood original scale of a map or plan, let's study what is shrunk scale. With time, the map is exposed to various temperatures, atmospheric changes, and wear and tear, which would result in the shrinking of the map. So, hereafter to read a shrunk map, instead of original scale, we must use a shrunk scale. As shown in the figure, our original map after a period got shrunk and the current drawing is Plan 2. Here, when measuring the distance AB in the shrunk map, it is obtained as 4 centimeters. The length AB got shrunk from 5 centimeters in Plan 1 to 4 centimeters in Plan 2. Without considering this shrinkage, if we take the scale given on the map, the length AB on the ground is obtained as 4,000 centimeters, which is incorrect. We know in actuality AB is 5,000 centimeters, so we have to calculate the new scale called the shrunk scale to incorporate the change in dimension. So the shrunk scale is calculated as shrunk scale or reduced scale is equal to original scale into the ratio of shrunk length divided by original length. Here, the ratio of shrunk length and original length equals shrinkage factor. Hence shrunk scale is equal to original scale multiplied by shrinkage factor. Let's determine the shrunk scale of the before example. In example 1, give as the original length equals 5 centimeters, shrunk length equals 4 centimeters. Scale is 1:1,000. Hence we start with determining the shrinkage factor. Shrinkage factor equals shrunk length divided by original length equals 4 by 5. Now, shrunk scale equals original scale into shrinkage factor equals 1 divided by 1,000 multiplied by 4 divided by 5. This gives 4 divided by 50/100. We need to convert this into 1:x form. That is 4 divided by 50/100 is equal to 1 divided by x. Hence x is equal to 1250. Therefore, the shrunk scale is 1:1250. As we know the shrunk scale, we will apply this on the shrunk length to obtain the original length. From equation 2, we have Original length equals shrunk length multiplied by shrunk scale. Hence, the original length on the ground, AB, is equal to 4 times 1,250 equals 5,000 centimeters equals 50 meters. Even if the dimensions of the map were changed due to atmospheric conditions, a shrunk scale can help to determine the original length on the ground. In addition to the explained equations, we can also derive equations for corrected length, area, and volume in map as well as on the ground. Let's discuss each, one by one. FYI. Shrunk length is also called as the measured length, while original length is also called as corrected length. Corrected length, corrected area and corrected volume on map. We know that corrected length or original length equals shrunk or measured length divided by shrinkage factor. Then, corrected area equals correct length multiplied by correct breadth. Applying equation 4, we get corrected area on map is measured area divided by the square of shrinkage factor. Similarly, we get corrected volume on map as measured volume divided by shrinkage factor square. Next is corrected length and corrected area on the field. Corrected length on the field can be calculated by initially considering the representative fraction, RF. We know that RF is equal to length on the map divided by the length on the field. So we have from the relation, corrected length on field is equal to the corrected or measured length on the map divided by the RF or original scale. We also know that shrinkage factor SF is equal to shrunk length on map divided by corrected or original length on map. Take out the value of corrected length on map and substitute in equation 7. This gives corrected length on field is equal to measured length divided by SF multiplied by 1 by original scale. This gives measured length divided by SF into original scale. But we know that SF into original scale is shrunk scale or RF of shrunk scale. Hence we get the final equation as corrected length on the field is equal to the measured length divided by RF of shrunk scale. Similarly, corrected area on field is equal to measured area divided by THRF of shrunk scale. This is a summary of all the equations related to shrunk scale in surveying. All the equations for determining corrected length in the map employ shrinkage factor, while those for corrected length on the field employ shrunk scale. Follow for the upcoming videos for related problems on shrunk scale in civil engineering surveying.